have a number multiplying it by pi, and then what'd you say after that? Subtracting pi over 2. Okay, so let's just see how this works. So n represents any number that you could plug in. So you could plug in a 1, you could plug in a -1, you could plug in a 0, because we have the left side of the graph, we have a right side of the graph. So just to make sure this works, if you plug a 1 in here, pi minus pi over 2 makes pi over 2. So that works. If you plug a 2 in here, 2 pi minus pi over 2 makes 3 pi over 2. If I plug a 0 in here, 0 times pi is gone, and then I'd have negative pi over 2. I could plug in a -1, have negative pi minus pi over 2, which gives us negative 3 pi over 2. So Virginia, can you kind of, is there like a way you can explain how you tried to come up with that?
I just said they're all the same distance away from each other, which is pi, which is why you multiply by pi, but because they're not set at 0, you have to subtract or add.
Or add, yeah, you could have subtracted or added. But all of your asymptotes, a set of asymptotes, has the same distance. Every pair of asymptotes is the same distance apart from each other, and that's pi. The reason it's pi is because that's your period. So that pi value is the distance the asymptotes are away from each other. And if I want to have one period graph, I could plug in a 1. If I wanted to find like the second period where it would go, I could plug in a 2. So that pi is there because that's the distance between a set of asymptotes. And then again, she said like it doesn't start at 0 because it's starting at pi over 2 or a negative pi over 2. That's why you have to either add or subtract, and either one would be acceptable. So you're either going to have to add or subtract that value of pi over 2, because that's how you're going to then create all of the pi over 2 values. So either one of those work, but like because the distance between one asymptote and the next is pi, that's why you need that pi in there. And then depending on the periods, that n value could help correlate or go with the number of periods that you have. Questions? So formula is a way to represent things that have a pattern. We called that a sequence last year in chapter 12. So a sequence is something that has a pattern. Asymptotes of tangent and cotangent actually have a pattern to them, so they really do make up a sequence. So Michael gave us the cotangent asymptotes as well. So Michael, what did you start with when you gave those?
I see is -2 pi.
-2 pi.
And then pi, 0 pi.
Pi, 0. We'll put in negative pi, yeah. So that would be 4. If you have a different set, that's fine. If you started at negative pi, you have 0 pi and 2 pi, that would be okay as well. So as long as you have 4 asymptotes in a row, wherever you start. You could start at 0 and go pi, 2 pi, 3 pi. So then if we want to come up with an equation or a pattern for those asymptotes, what would that equation look like? So these are multiples of pi. What do you think, Chelsea?
Wouldn't it just be x equals n?
Yeah, so some number times pi. So we could use a 0, and you'd get the asymptote at 0. You could plug a 1 in and get 1 pi. A 2 would be 2 pi. A 3 would be 3 pi. So if it's a multiple of pi and there's nothing else, because it doesn't have to start at a different value, then you just have that number that's a multiple of pi. So this n here means it's a multiple of pi. Any number times pi. Questions? So that's just kind of getting you to like think about kind of algebraically, because that really is going back to algebra. How could you take a pattern for asymptotes but kind of create it into an algebra equation? So today we are going to look at graphs already drawn for you, and we're going to work backwards by trying to write the equation. So we did this with sine and cosine. We found all those letters and then used the letters to try to create an equation. We're going to try and do that same exact thing. In your packet, I think it's page 45. I should remember this. This is the third time. Pretty sure it's page 45. So if you can turn to page 45 in your packet. Oh, wow. You added so many. Yeah. And then the other thing that if try and find through the notes that we did just on the graph paper, the first thing that we graphed, and this was just on Wednesday, on the extra graph paper that I gave you because we didn't do notes in the packet on Wednesday, we just graphed the basic tangent function. And we graphed it from negative 3 pi over 2 to positive 3 pi over 2. And we listed the asymptotes, we listed the intercepts. See if you can find that note sheet. Like it wasn't in your packet because it was just a separate piece of graph paper that I gave you. And unfortunately, I have no clue what I did with mine. I think I threw it away. I had it, and I feel like it must have been thrown away. It's sad, and I have to make new notes for myself. Anybody find theirs? Yes. Sorry, you're in the front. The bummer about being in the front. I'm going to steal Sabrina's. I just want you to kind of look at this so you can see like what a tangent graph, a basic tangent graph looks like, so that you see kind of like where we're going to be trying to focus our attention when we're writing an equation. So if you didn't find it, Sabrina kindly let me steal it from her. I'm not even really sure I asked. I think I just took it. So here's Sabrina's tangent graph. And a couple of things to notice about tangent is it's increasing. So a tangent graph goes up from left to right. That's one thing to kind of think about when we're trying to write an equation. So her tangent graph is increasing from left to right. The other thing would be where is it centered at? So its initial point or its starting point around that x value of 0, it is an actual point at 0. So tangent has a point at 0, 0, because when we go to look at a phase shift, we're going to be looking at the x-intercept and where that x-intercept is located, because that's going to tell us how far it's shifting from 0. So that's what a phase shift is. Phase shift is, if it starts at 0, how far are you shifting left and right? So with the tangent, it has to be positive, an increasing graph, and we're going to be looking at that x-intercept. Where's an x-intercept? Because that would be our phase shift. Cotangent, the other graph we've kind of been looking at, is a decreasing graph. So it does the opposite because they're reciprocals. So tangent increases, cotangent decreases. But the other difference with tangent is that at the x equals 0 value is an asymptote. Because if it's 0 for tangent, 1 over 0 has to be an asymptote. So when we go to find a phase shift for cotangent, we're going to look at the asymptote and see where has the asymptote moved from the value of x equals 0. So tangent is increasing, and we're going to focus on the x-intercept. Cotangent is decreasing, and we're going to look at the asymptote for the phase shift. So that's to help us kind of get a phase shift. So if you look at the first graph in your packet, just by looking at the graph, which graph does it look like? It's either tangent or cotangent, one or the other. Sabrina? Or not Sabrina, sorry, Virginia. Yeah, this looks like a cotangent graph because it's decreasing. So decreasing going down from left to right. But we're going to also write a tangent graph for it. So our goal is going to be to write both. So to start off, when we tried to write equations, we started with D, which was that sinusoidal axis, so the middle of the graph. So if you look, there are 3 points that are graphed on there, and then there's 2 asymptotes, which is how we've been graphing. Where would the middle of the graph be? Chelsea? At 1. So the middle of the graph is at 1. That's our sinusoidal axis. That's the new x-axis because it's kind of moved up and shifted vertically to that point. So the D value is 1. So you're finding the center of the high point and the low point. That's your D value. That's the middle of the graph. What would you do to find A? How would we find A, Virginia? Yeah, so the distance from that sinusoidal axis to one of the points, whether you're going up or down, that distance is 3, and that's A. So after we found those things, that does everything we need with y, now we need to think of the x value. And one of the x values we looked at was the period. Well, when you have tangent or cotangent, a period is the distance from one asymptote to the next. So you just need to pick a pair of asymptotes and find the distance from those asymptotes. So here's one asymptote, here's the second. What is the distance from one asymptote to the next asymptote? Chelsea? 2. So the period is going to be 2. So counting by whole numbers on the bottom, one asymptote is at 0, the second one is at 2, so the distance in between there is 2. But if you're finding B, the period would be pi, the typical period, over B is going to be equal to 2. So to find B, our typical period for cotangent and tangent is pi. So we take pi divided by B, set it equal to 2. That means B is pi over 2. Because we can't use the period in the equation, we have to use the B value in the equation. Questions on those three, Lily?
Why is it pi when normally, like, when we did it with cosine and sine, it was like pi?
Because for sine and cosine, for it to go through a full like phase of the graph, it took 2 pi. Like for sine, it has to go up and down and then come back in the middle. Whereas once a graph starts repeating, then you have a new period. So this graph just starts repeating faster than sine and cosine start repeating. So the distance of sine and cosine for it to repeat, you have to go all the way through 2 pi. Whereas once you have one curve and then you have a second curve that looks identical to the first, then you have a second repetition or a new period of the graph. And it's just the way the ordered pairs the points work. It just starts repeating sooner. Other questions? So the last thing that we're going to find is the phase shift. And we're going to find them for both. So we're going to find a phase shift for the cotangent, and we'll do cotangent first since this looks like cotangent. And then we'll also find a phase shift for the tangent. So when you're finding a phase shift for the cotangent, you're using the asymptote. For the tangent, you're looking at the intercept. So what would the phase shift be for cotangent? Michael?
Is there none?
There isn't any. Why, Michael?
Because there's some asymptote 0.
Yeah, there is an asymptote at 0. And if you're looking, the goal of a phase shift is to see how far has it shifted from 0. Well, it hasn't if there's an asymptote there. So for cotangent, there is no phase shift. The tangent, we're looking at the intercept. Well, the intercept is going to be the place where it's intersecting with the sinusoidal axis. Wherever that sinusoidal axis is the intercept that you're looking at. So we need to find out how far that intercept has shifted from its typical location when the x value is at 0, or when you're on the y-axis. So Chelsea, how far has that intercept shifted?
1.
Yeah, it shifted to the value of 1. So the tangent, you're finding that point, the middle point. Where is it on the sinusoidal axis? How far has it shifted? It's supposed to be at 0. X is supposed to be 0. So how far has it shifted from 0? That's your phase shift. So we have everything we need now. We have A, B, not C, but we have A, B, D, and then we have the phase shift, which is that C over B value. That's the number we put in parentheses. So when we go to write the equation, we'll start with cotangent, since this graph looks like cotangent. We said A was 3. We have a cotangent graph. B is pi over 2 because the period was 2, so now B is pi over 2. There wasn't a phase shift, so that means you just place an x next to the period. There's no parentheses if there isn't a phase shift. And then the last part, the D value, shifted up to 1, so that D value you just add to the back. And then we're going to write one for tangent. So we still have a 3. We're changing it to a tangent function. Pi over 2 is the same as well. But there is a phase shift because it's shifting 1 right. So that means inside we would have x minus 1. It's moving to the right. So x minus 1 goes inside. And then there's a plus 1 outside. Now there's one thing that we have to tweak with this equation. Anybody know we have to kind of fix for Virginia? Yeah, why is it a negative 3?
Because the tangent graph usually goes up.
The tangent graph usually goes up. So that's what a typical tangent graph should be increasing. So if this is decreasing, that means we have a negative tangent graph. So when you're writing an equation for a tangent or cotangent graph, one will always be positive, and that's the one that you're given. The other one has to be negative because it's the opposite of what it is. So it's the flip, the reciprocal of what you see. Questions? So there's a second one down below. See if you can find the center of that graph, find D, get your A value, and then the period is the distance between the asymptotes. So to get the center, you're taking the high and the low point, finding the middle of them. There's where do you think the middle of the graph is?
Negative 1. Wait.
Mm-hmm. So negative 2 will be the center of the max and the min that are points. They're really not max and min, but the highest and lowest point that's drawn on there. So our D value is negative 2. And then Eris, what is the distance from the middle to the next point?
Maybe 1 or negative 1.
Just either, we'll just keep it as 1. You could say a negative 1 as well if you're going down. And then finally the period, if you go from one asymptote to the next, and you can use either pair because the period is going to be the same. Jenna, what do you have for the period?
Pi.
Yeah, it's just pi. So from 3 pi over 4 to 7 pi over 4, that distance is pi. So to get b, take pi divided by b, because that's our standard period for tangent and cotangent. Set it equal to the period that we found. So Libby, b would just be 1, yeah. Because pi is the standard period. So that means the b value is 1. This graph looks like a tangent graph. So we'll find the tangent phase shift and the cotangent phase shift. So for the tangent phase shift, you're finding that center value, the point that crosses the sinusoidal axis. And there are 2 of them, so you can write it either way. Sabrina, what would that phase shift be for tangent?
Would it be a pi over 4?
Yeah, so it's pi over 4 and it's shifting to the right. So right here we've got pi over 4. So the point that you're looking at where it goes through the sinusoidal axis. Sabrina, what do you have for the cotangent phase shift?
Would it just be the opposite of that and negative pi over 4?
Yeah, so you could use negative pi over 4 because it's going to the left. That's where the asymptote is. You could also use 3 pi over 4. That's where another asymptote would be located. So either one of those work. Okay, it depends on where you want your graph to start. So you can either say it's shifting to the left to negative pi over 4, or it's shifting to the right to positive 3 pi over 4. And then the last thing we have to do is write the equation. So Chelsea, if we're writing a tangent equation, what is it going to look like?
Y equals tan x minus pi. And then minus 2.
Yeah, -2. So tangent's positive, it's an increasing graph. And then the b value is 1, so you could have a 1 value there, but we don't usually write that. But it's shifting pi over 4 to the right. So that's why it's x minus pi over 4, and then down 2. And then for cotangent, Libby, do you have a cotangent?
Negative cotangent, x minus 3 pi over 4 parentheses, and then minus 2.
Or you could have x plus pi over 4. Either one of those work. You could even have x minus 7 pi over 4. Any of the asymptotes is a phase shift. But that one's negative because this is the reciprocal of a positive cotangent graph. Questions? I think writing equations for tangent and cotangent, I feel like they're a little easier than sine and cosine as long as you know what piece you're looking at. So you're either looking at the point that's crossing the sinusoidal axis or you're finding an asymptote, which is pretty easy to find. So on the back, we're going to see if we can write an equation for secant and cosecant. So if your graph isn't an increasing curve, going all the way up or all the way down, decreasing curve, then it can't be tangent or cotangent. But if it has like parabolic looking shapes, these are true parabolas because they're bounded, but they kind of look like parabolas, that will tell us that we're dealing with secant or cosecant. So if you look at these two pieces here, I would again find the center. Like I think finding D is the easiest thing to start with. And that would be the middle of the max and the min that's drawn. So it's still the middle of the highest and lowest point, even though we have a different shape of our graph. Where's the middle of this graph? Chelsea?
Would be 0.
Yeah, it is 0. Because you have a point at 2 and a point at negative 2. So the middle is at 0. And then if you want, if it makes it easier for you to look at, you can draw in the sine or cosine graph. So once you have that middle, your sine graph touches the asymptote and the middle of the graph, the sinusoidal axis. It goes up to the max, it touches the asymptote. So right here is part of my sine graph. Goes down to the min and goes back and touches the asymptote. So if you like looking at sine, because we've done sine and cosine so much, you can feel free to sketch in that sine curve. Or your cosine curve, depending on the shape of your graph. But this one looks exactly like a sine curve when she sketched that in. Sometimes it makes it easier to find an equation for sine, just because we've already done that. So A, and then our period, which helps us get B, and then the phase shift. So Asia, if the center is at 0, how far are you stretching up or down to get to that max or min? 2, yeah. The graph that's drawn up here is one full period because a sine goes up and a sine goes down and then starts back and ends at the middle. So from one asymptote to begin with, negative pi over 4, to that final asymptote, 3 pi over 4, that's the whole period of the graph. That whole distance is our period. So sine and cosine, or secant and cosecant, you have to make sure that you've got that full period. So you should have one parabola and then the other parabola. Anybody know what the distance is from negative pi over 4 to 3 pi over 4, Virginia? Yeah, that distance is pi. So when we're finding the B value, because it's sine and cosine, or secant and cosecant, it's 2 pi over B is equal to pi. So in this case, B is 2. So tangent and cotangent are the only ones that have a period of pi. And then the last thing, we want to find the phase shift. So we're going to look at where the sine touches the sinusoidal axis, that's cosecant. And for the secant, we're looking at the cosine graph, and the cosine graph, we're always looking at that highest point for the cosine graph. So a sine graph would start in the middle. A cosine graph would start up high. So that means the secant starts where the cosine starts. The cosecant starts where the sine starts. So the sine here starts at negative pi over 4. The cosine is on the y-axis, so it doesn't have a phase shift. That means the secant doesn't have a phase shift. So we had an amplitude of 2. We're now looking at the cosecant. We said B was 2, and then it's shifting pi over 4 to the left, so it's plus pi over 4. So d was 0, so there isn't a d value. And then if you don't want the secant to have a phase shift, it would just be 2x. Questions? I wanted to pass your test back, but I think I have like a minute, so you can keep your test if I can get it back to you quickly. Your homework is on the assignment sheet. It's page 52 and page 43. So page 52, there are 4 graphing problems. Page 43, you have 4 equations that you're writing, 4 graphs that you're writing the equations for. These tests, feel free to stop by and see me, ask questions, we can go over those. You can keep these for now, I'll collect them back from you on Monday, and make sure that you get them. We didn't have a fire drill, we had plenty of time. Let's see. Okay, everybody got theirs, right? Have an awesome weekend.